Hi, I'm Yungnickel, and this is the second video showing you what we get up to in the lab. As some of you know, whitebait have earbones, also known as otoliths, and like a tree with growth rings, instead of representing a year for each day the tree is alive, a whitebait puts on a new growth ring every day. This video goes through the process Eimear, another member in our research group, has been using to age whitebait, specifically inanga. So let's go and meet her.
Hi, my name is Eimear and I'm a PhD student at the Marine Ecology Research Group, and I spend a lot of my time working with the earbones or otoliths of inanga. So what I do is I look at the characteristics of the earbones of this species from different parts of New Zealand, so from the Bay of Plenty right down to Canterbury, and from the earbones I can figure out the age of the fish and their growth rates. And I essentially compare these characteristics between the different places in New Zealand, because this gives me an insight into their marine life phase, which we know the least about. It takes approximately an hour and 20 minutes per fish to extract the otolith from the fish's head, to prepare it, to polish it, to photograph it, to age it, and to do the data analysis. And thus far I have probably aged about 1,000 inanga.
Hi, my name is Jessie and I'm a research assistant at the university, and I'm helping Mark and Eimear with aging whitebait primarily, and today I'll be helping guide you through a few steps of that process.
So now we've got the inanga under the microscope and we've got a close-up of its head here. I'm going to extract the otolith out of it. It's quite difficult as I'm doing this through a camera rather than the actual microscope, just so you guys can have a look. But if you look really closely, we can see the right otolith right there. It's just a little disc, and there's one on the other side as well. So what I'm going to do is cut its head open. And that exposes the brain there. You can see the brain. Get rid of the brain to make it a bit easier to see what we're doing. Okay, and then here's the right hand otolith. Okay, and now I have the otolith, the right hand otolith, on the end of the forceps here. So with the otolith on the end of the forceps here, you can get the paintbrush and take off the excess tissue. There's the otolith right there in the centre. And we might have a zoom, have a good look at it. Yeah, so that's an inanga otolith. It's got a little bit of tissue still on there. Here we've got some crystal bond. It comes in a tube like this, and it gets broken up into little pieces. It looks like glass, and this is used to put on to the slide to get the otoliths to stick to it.
It takes about 10 seconds to melt. And so once it's fully melted, take it off and it hardens. It's completely rock solid in just a few seconds after it cools. Keep the otoliths in these trays. Each well has one otolith, 2 for each fish, and they're very tiny. So you have to use the microscope to see them.
So it's taken off with a wet paintbrush, as they're very, very tiny.
So with the otolith sitting on the crystal bond, put it back on the hot plate and give it a few seconds to soften the crystal bond again. And then moving pretty quickly, because that crystal bond rehardens quickly, we bring it off the heat and tap the otolith all the way down to the bottom of the slide, right in the center of the crystal bond. And now it's pretty solidly set.
Now we have different grades of polishing film. This is basically like really, really fine sandpaper. And the whole idea is that we have to take the top off the otolith to expose the core to actually see the different growth rings.
The yellow is the slightly coarser grade, and the white is a little bit finer. So we always start with the yellow, spraying it down with water first. And the otolith has a lot of crystal bond on the top of it, so we have to polish that away to actually get back down to the otolith. And so with the water, we just put the slide face down so the otolith is facing into the grit, and then very lightly just use your fingers to hold the edge of the slide, so you're not actually pushing pressure down, you're just holding it and drawing some circles to polish away that crystal bond. And we periodically check. To see how far into the crystal bond we've gone. So what you're seeing on the screen is what I can actually see down through the microscope here. So you can sort of see that orangish color is the otolith, but there's still a lot of crystal bond on there, and that's why it looks really distorted. Push through all the superficial layers of the crystal bond, and you can actually see the difference once I hit the otolith. So this is still crystal bond, the otolith is still under this crystal bond, but this is, the otolith is right on the surface, there's no crystal bond above it. And so you pretty much never get the otolith clear in the first polish. So you have to flip it a few times, kind of going to the hot plate again, warming up the crystal bond, flip over the otolith, and go back and forth a couple of times till you can shave it down to a very thin, flat layer.
Now Jessie has to flip the otolith over so she can sand it down again.
Polish the other side.
And polish the other side.
Polished it pretty much as far as I can without over polishing it. And so as you adjust the focus, you can start to see the rings showing up. So now I'm a little bit closer into the core in the middle, and I can switch the focus, and you can start to see the rings.
As we're videoing on a computer screen, that's why you're seeing the big lines going through, but it's a clear picture for us.
The last step before we're ready to start photographing is getting the slide cover on top of the otolith. So we always use a drop of oil, and those little tiny surface scratches that were left, the oil helps to get rid of any distortion from that, so you just see a clear picture. And it also keeps the cover slip on the top of the slide. The oil is on the slide, and so to make sure that there's no air bubbles, we use tweezers to lay it on there so the oil can get a good grip, and then it just slides out from the center. You can see that otolith right in the middle there. And then last thing is adding a little bit of nail polish to make sure that the cover slip stays in place. Just a drop in each corner. And once it's dry, the cover slip shouldn't move anymore. Here's our otolith, and this is 10 times magnification, so we're not zoomed in too far. And you can sort of see the rings at this magnification, but not really very well. So we usually go up to 40 times magnification. So I always start the photographs from the very edge of the otolith. And so you work to get those couple rings right on the very edge in focus. And you can adjust the exposure and the white balance to get the image as clear as you possibly can. It's a very high definition photo, so it takes about 20 seconds for each image to actually capture.
Basically, we come upstairs after we have taken the photograph on the microscope, and we open up each of the pictures, and here you can see a picture of the otolith, and it's zoomed in so that we can actually see each of these rings. And then I use a software to basically draw a line on the ear bone, and then the software will calculate where each of those rings are. So it basically counts them for me. Here you can see here those yellow lines represent where it has counted each individual ring. And it also measures the distances between each of these rings, which basically gives me an estimate of the growth of the fish. So by counting each of these rings, that's how I age the fish, and the distances between them indicate the growth of the fish. So the distances between the rings are far apart when the fish is growing fast, and for example when the rings are quite close together, that can be an indication that the fish is going through a slow growth period, maybe when it's reaching sexual maturity.
So that's how you age a whitebait. It's a long process, but it tells us a lot about the early life history. We hope to do it for the other species, koaru, panda cockapoo, giant cockapoo, and hopefully short drew as well.